It's a new day on SpaceX Daily, episode 31. I'm Patrick in Vancouver. Today is July 13th, 2026. From Starbase to orbit, here's your SpaceX rundown. Flight 13's propellant and avionics upgrades move Starship one step closer to demonstrating the rapid reuse that would collapse launch costs. Regulators cleared the integrated test flight window opening July 16 at Starbase. The mission uses the second V3 Starship and Super Heavy stack. Teslarati reports a series of hardware and software changes from Flight 12, including updated propellant management and avionics. These revisions target improved performance during the boost-back burn and separation sequence. The launch window opens at 6:30 p.m. ET from Starbase in South Texas. This marks the second flight of the V3 vehicles and builds directly on Flight 12 results. Listeners should watch for whether the new configuration supports the first V3 Starlink deployment attempt. Starship's ongoing flight test campaign at Starbase keeps booster catch and full reuse as central goals. Today's clearance advances the open question of orbital refueling demonstration timeline by testing revised systems in flight. The vehicle carries revised tank baffles and sensor suites to handle higher propellant flow rates. Updated guidance software aims to tighten the boost-back corridor. The second V3 stack also incorporates refined heat shield attachment points carried over from Flight 12 lessons. These incremental hardware steps directly address the open question of booster turnaround time between flights. The mission remains the second integrated flight test with V3 Starship and Super Heavy vehicles. Changes focus on propellant management and avionics refinements that build on prior data. Starship's flight test arc at Starbase continues with these targeted revisions. Success here would move the reuse cadence goal forward by validating higher flow hardware in a real ascent profile. With Flight 13 now confirmed, we turn to what the upper stage will actually carry. 20 V3 Starlink satellites are manifested for the Flight 13 upper stage. The deployment profile tests new dispenser hardware and release sequencing. Success would mark the first operational use of the V3 bus on a Starship mission. Starlink's constellation growth receives its first V3 test aboard Starship. The deployment sequencing data will inform how the higher throughput bus integrates with existing laser link and direct-to-cell plans. While Starship dominates the near-term test calendar, Falcon 9 keeps the cadence alive on the Florida coast. A Falcon 9 is scheduled for a late-night liftoff from Cape Canaveral carrying a commercial payload. The mission continues the high-cadence reuse campaign on the Florida pad. Range and weather checks remain the final gates before the overnight window. Falcon 9's reuse counts keep climbing with this Florida flight. The overnight timing tests operational flexibility at the Cape, while the annual launch rate ceiling question stays open for attentive listeners. As launch rates press against existing infrastructure limits, one study explores an unconventional workaround. Federal agencies are studying conversion of decommissioned Gulf of Mexico platforms into offshore launch sites. The concept would add fixed infrastructure without new coastal real estate approvals. Early engineering reviews focus on deck load ratings and exhaust plume management for vehicles the size of Falcon 9. Launch infrastructure readiness at existing pads remains a tracked constraint. This offshore study explores an alternate path that could ease pressure on Starbase and Cape turnaround times if deck ratings prove sufficient. Meanwhile, Starlink continues expanding its ground footprint with fresh test data from a new continent. SpaceX received permission to conduct initial gateway station tests in South Africa. The trials will measure uplink and downlink performance ahead of potential service licensing. Data collected will inform terminal certification and spectrum coordination for the African continent. Starlink's constellation expansion continues with these gateway tests. Direct-to-cell capability ramp and subscriber growth questions receive fresh performance data from the planned South African links. On the AI front, Cursor released the Sand agent for multi-file code editing and terminal execution inside its workspace. The early build is being tested against competing agents from Anthropic and OpenAI. Integration work with Grok models continues in parallel with the public rollout. Cursor's position as the point where Grok reaches developers gains another tool with SAN's multi-file and terminal features. Tech Times noted that SAN development precedes any major SpaceX roadmap updates that could affect compute allocation between orbital and terrestrial clusters. The timing keeps developer tooling in focus while larger infrastructure questions remain open. Cursor's agent work therefore sits alongside ongoing Grok integration testing without yet intersecting new orbital compute decisions. While SpaceX pushes vertical landing, other teams are testing alternative recovery geometries. Worth keeping an eye on, a South Korean team demonstrated net-based booster recovery on a sea platform. The approach uses a different geometry from tower arms and targets lower landing precision requirements. The test provides comparative data on structural loads during ocean recovery. The method reduces touchdown precision demands but adds skirt loads that future trials must quantify for larger vehicles. From an engineering standpoint, the central downcomer inside Super Heavy's liquid oxygen tank is essentially a Falcon 9 scale methane transfer line running the full height of the booster. By routing chilled propellant through this large diameter pipe rather than relying solely on the upper tank dome, designers keep the Raptor inlet conditions stable even when the vehicle is nearly empty of methane. The pipe's volume adds meaningful propellant mass that simplified animations omit, directly affecting the true mass fraction available for the boost back and landing burns. Internal volume calculations must therefore include the downcomer cross-section to avoid underestimating available methane for the final descent sequence. This plumbing choice trades added dry mass and fabrication complexity for operational robustness. A smaller, lighter downcomer would reduce structural loads but risk vapor ingestion or pressure drop at the engines during the critical final seconds of flight. The current design therefore accepts a higher idiot index on the tank assembly in exchange for repeatable engine starts across multiple flights. The same principle that made Falcon 9 reuse economical once the landing legs and grid fins were refined. The downcomer diameter itself becomes a first principles variable, large enough to maintain flow at low tank levels, yet integrated without compromising the LOX tank's primary structural path. If the downcomer can be produced at scale with minimal rework between flights, it lowers the cost per kilogram delivered to orbit by enabling the booster to fly again with only routine inspections. The next data point will come from Flight 13 telemetry on propellant residuals and engine inlet temperatures. Any measurable improvement in landing margins would validate keeping the large internal pipe rather than pursuing a lighter but riskier alternative. Raptor engine program continuity benefits directly since stable inlet conditions reduce the variables that must be requalified after each landing. And a quick market note, SPCX closed at $140.74, down 3.5%. Before we go, Starship Flight 13 remains the clearest near-term test of whether incremental hardware changes can deliver measurable reuse gains. That covers everything worth knowing about SpaceX today. SPCX is trading at $140.74, down 3.5%. A quick rating on Apple Podcasts or Spotify goes a long way. I'm Patrick in Vancouver. See you tomorrow, and before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Plantarian Daily, daily breakthroughs in science, health, and longevity. Find every show free at naranetwork.com. New to the network? naranetwork.com/start-here. Picks the right daily briefing for you in about 2 minutes. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.